oceanographer, and the process that's happening today I get concerned about is ocean acidification, which is a pretty deep topic and it's an active area of research. So I thought I'd start very simple here with a little chemistry lesson to talk about what is the pH scale. So I actually wrote some intended learning outcomes that I wouldn't have normally done, just because I'm thinking about this class. I hope you'll be able to explain what the pH scale is, give some everyday examples of things that have different pHs, and what's actually the relative acidity between solutions that have different pHs. So pH is just a unit of measure of acidity, and acidity refers to the concentration of hydrogen ions, or H+, in a solution of water. So chemists use something called the molarity scale, and a mole is just a number of things. It's a very large number of things, something like 10 to the power of 23. So that would be 23 zeros following the number 1. If you ever learned Avogadro's number in high school, that's Avogadro's number. But most solutions have concentrations of the hydrogen ion much less than 1 mole in a liter of solution, say. So if you were actually to write out the concentration of hydrogen ions, you'd have to write things like this, 0.0001. But the other thing about hydrogen ion is that it can vary by orders of magnitude. So you might have to write something with 5 zeros or something with 2 zeros. So what chemists have done is just put this on a logarithmic scale. So it's a negative logarithmic scale. So a pH is actually an exponent where 10 to the minus that pH would tell you the concentration of the hydrogen ions in a particular solution. So this is a negative logarithmic scale. That's the equation again. So a pH of 3 would mean you have 0.001 moles per liter of hydrogen. pH of 6 would mean you actually have a smaller amount of hydrogen ions, and you'd have 0.000001 moles per liter. So the difference between pH 3 and pH of 6 is not a factor of 2, it's actually a factor of 1,000. The other thing to remember is this is a negative logarithmic scale, so when you decrease a pH unit, then you're increasing acidity by increasing hydrogen ions. So 1 pH unit going down is actually a factor of 10 increase in acidity. Increasing by 2 units would be not a factor of 2, but a factor of 100, 10 to the power of 2. So hopefully this is easy for you guys. Which solution is more acidic, 5 or 8? Just put up the number with your hand. Okay, that's right. And how much more acidic is that solution than a solution of pH 8? A factor of 1,000, right? 10 to the 3. So, does anybody know some common household liquids that are very acidic? Any guesses?
Lemon?
Yeah, lemon juice. Where do you think that might be on the pH scale?
3. Where's water? What's water?
2.
Okay.
Where is water?
Ooh.
7.
So pure water is at a pH of 7. Lemon juice is here at 2. A lot of us are familiar with this solution. This is fairly acidic. But the interesting thing is that different types of water have different pHs. So most water that we'd find outside, like rainwater, is not a pH of 7. It's actually a pH of something like 5.5. It's because there's carbon dioxide in the atmosphere. And when carbon dioxide dissolves in water, it becomes an acid. So carbonated soda has carbonic acid in it. and that makes it more acidic with the lower pH. The ocean is actually less acidic than pure water. It has a pH of about 8, and that's because it has different minerals dissolved in it that decrease the hydrogen ions present, so it has a higher pH. Ocean acidification has to do with the fact that we're putting more and more carbon dioxide into the atmosphere, so as it dissolves in the ocean, we're going to get more acidic, which means decreasing pH. And just to give you an idea of the scale that this is happening, people have been going out to the ocean and measuring the pH of the water over 30, 40 years. So this graph shows 1970 to 2010. This is the pH, and you can see the pH has this trend of going down. It's only gone down by about 0.1 pH units. And that sounds small, but you always have to remember it's on a logarithmic scale. So a 0.1 decrease in pH translates into 25% more acidic water. And if we were to go further into this, we talk about, how can that affect life in the ocean? And it turns out to be a little bit scary. But I'll end there for today's lesson.
Cliffhanger.